American Business Review, featured on national television, is an industry platform where the spotlight seeks out and shines on the creators and innovators. Because of its commitment to promoting progress, this editorial series recognizes Hypres. The world of business. It's never been more competitive, more challenging, more rewarding. Growth rates, interest rates, franchising, globalizing, staying private, going public, online, bottom line. The world of business. It's about having good ideas, good technology, and good information.
Hello, I'm Morley Safer. Welcome to our program. Often the vision of few creates the path for many. This is especially true in the competitive world of business. One good idea can set a trend in motion and generate hundreds of related business opportunities, as we're about to see.
We are constantly pushing the limits of communication technologies. Just as the limitations of vacuum tubes were surpassed with integrated circuits and semiconductors, the next generation, superconducting technology, is ready to eclipse the speed and bandwidth capacity of conventional circuits.
Superconductivity itself was discovered in 1911. In the early 1960s, there was a prediction of a device, which we confirmed shortly afterwards, which would be useful in electronic circuits. The first use of that device continued through the 70s and 80s, particularly at IBM and in Japan. But it became clear that those devices wouldn't compete particularly well with progress in silicon and other semiconductors. But in the late 80s in Moscow, a different way of using the device was proposed, and that now holds promise for producing the very highest speed electronic circuits.
Much like the transition to faster modes of transportation required the leap to the dimension of heights, the next generation of circuits requires the acceptance of the dimension of temperature and the leap to cold.
In general, resistance goes down as you cool off a piece of metal. But in particular, if you go low enough in temperature, certain metals become superconductors.
The low temperatures required for superconductors are attained using cryocoolers, which are compact refrigerators.
There was a problem in the 1960s and 70s in that we were using materials like lead films in these devices, and they were not particularly reliable. In the 80s, mid-80s and 90s, we've developed a different materials technology which is based on niobium, or two niobium films separated by a thin layer of aluminum oxide.
Westchester County in New York has been called Niobium Valley because of scientists' continued work on superconductor applications. There, companies such as Hypres are helping lead the digital superconducting revolution for telecommunications.
By changing the signal to digital format immediately after the antenna in a base station, thanks to the superconducting device, a number of benefits ensue. On the one hand, it allows the elimination of a number of pieces of hardware that used to be used to process the analog signal. On the other hand, it allows that same station, thanks to the power of software that's brought to bear, to accommodate any kind of communication protocol. Perhaps the most important impact is a more efficient use of the bandwidth of the spectrum. About 10 to 100 times more capacity is enabled within the same bandwidth.